In this video, we look at how we can use a spreadsheet to show a probability distribution and how we can create graphs and find expected values. So for this, we're going to look at a simple game. The game involves flipping three coins and counting the number of heads that we get. So here are all the possible outcomes, tree diagram indicating all of the possible outcomes. So we're going to let our random variable x, let x represent the number of heads. So if that's the case, the elements of our random variable, how many heads could we possibly have? Well, we could have 0 heads, we could have 1, we could have 2, and we could have 3. So those are all of the possibilities. So let's have a look here. Let's create a column for the x values. And we've determined that the elements of our random variable could be 0, 1, 2, or 3. The next column that we need are the probabilities of these things. So the probability that x equals x. Sometimes this is just written the probability of x, and sometimes it's written as the probability that x, the random variable, is equal to x. So this just means what is the probability that the random variable is equal to 0 in this case, the probability that the random variable is equal to 1, and so on. So in order to find the probability, we need to look at remember that our random variable is the number of heads right up here. So we want to look at what's the probability of getting 0 heads. Well, the only way 0 heads happens is right down here at the bottom. So that's 1 out of 8. I'm going to type in an equal sign at the beginning, 1 with a slash, and then 8. The slash can be found on the number pad or in the bottom right hand corner of your keyboard. By putting an equal sign first, the spreadsheet's going to convert that fraction to a decimal for us. So you can see it converted 1/8 to 0.125. Next up, we're going to find the probability of getting 1 head. So 1 head happens, let's see, right here, that's 1. Right here is 2. And right here is 3. So happens 3 out of 8 times. So this is equal to 3 out of 8. And again, the spreadsheet will convert that to a decimal for us. Probability of 2 heads. Here's 1 here. There's 2. There's 3. And those are all the possibilities. And the last one here, the probability of getting 3 heads, that only happens right here at the very top. So that's probability there is equal to 1 out of 8. Now these, we've already determined that these are the only possibilities. So if we add up this column, we should get 1. We should get 100%. So the probability of getting a 0 or a 1 or a 2 or a 3 should be 100%. There are no possible other outcomes. So let's just verify that that's true. I'm going to type in an equal sign. It already wants to calculate the sum, so we could actually just click on this. But if that doesn't pop up for you, or you're using a different program where it doesn't automatically recognize, you just type in the word sum, put in a bracket, and then highlight the numbers that you want it to add together, and then hit enter. And you can see the sum here is 1 or 100%. So there are the random variable values, the elements of the random variable, their probabilities. Now let's look at how we can find the expected value. So the expected value is just x times the probability that x happens. So we want to take the x value and multiply it by its probability. Again, the spreadsheet is good at that. Type in an equal sign, click on 0, hit the times symbol, which is a star, can be found by pressing Shift 8 or on the number pad of your keyboard. And I want to multiply it by the probability. Hit enter, and the calculation is done for us. Next up, we could repeat that 3 other times, or we can use the nice feature in this spreadsheet here, the little square in the bottom right hand corner. If you move your mouse over it, it will turn into a set of crosshairs. You can just click and drag down, and it will automatically do those calculations. And if you're not sure it did the calculations correctly, if you click on the cell right at the top here, it will tell you what it's doing. So this one is A8, so A8 times B8 is in fact doing the multiplication or the product of these two things. Now remember, the expected value is the sum of all of the x times the px's. So we should be able to now sum this column. So it's the sum of this column right here Sorry, I forgot a bracket after my sum. So the sum of this column right here. And we hit enter, and it gives us a result of 1.5. I'm just going to type in brackets here that this is in fact the expected value. Expected value. So that means that if we were to perform this experiment a whole bunch of times, the average number of heads that we should get when we play this game of flipping 3 coins should be 1.5 heads. I know it seems odd to get 1.5, but again, this is a long-term average. Okay, so let's go ahead and make a graph now of this probability distribution. We have the table, we've calculated the expected value. I'm just going to get this out of the way. Let's now make a graph of the results. So in order to create a graph in the spreadsheet, some of you might know how to do this already. We're going to highlight the X column and the probability column. Click on Insert, choose Chart, and we get a chart that looks like this. Now I'm noticing here, sometimes we have to clean this up a little bit. So I'm noticing, for example, in this chart, for whatever reason, it's giving me 0, 1, and 2 for my X values. It's not giving me 3. So I'm just going to go in and fix that. So here, under the X axis, I'm going to click on the 1, 2, 3. That's allowing us to say, hey, where are these values coming from? And I can see that for whatever reason, the spreadsheet didn't go all the way to the bottom. I will actually want it to go all the way from here. And I'm just going to hold down the Shift key to select all of those, A4 to A8, and click OK. Now you can see there's nothing in that column for 3. There's nothing on it. There's no Y value, so something happened with our Y value as well. I did this graph earlier and it didn't have this issue, so it's probably good that it came up so that we can sort it out. So again, same sort of thing. We're going to double click here, and notice here that it's saying go from B4 to B7. We actually want to go from B4 all the way to B8. So it didn't include that last value for whatever reason. And now you can see that we have a graph that depicts our probabilities. So the random variable values are along the bottom. So again, this is the number of heads that we can expect. And here's the probability of those heads happening. You can see that our graph matches quite nicely with our table. It's probably worth giving this a better title than px equals x versus x. So we might actually call it something along the lines of the probability versus the number of heads, since that's what this graph is about. And down here we might add in that this is our x value, but it's also the number of heads. Just to make it a little more clear about what this graph or chart is all about. So there's our bar graph. Notice it is a bar graph. The bars are separated by spaces, and the reason for that is that this is discrete data. We can't have 1.5 heads or 2.5 heads, and so on. I know we talked about expected value being 1.5. Again, that's an average, right? So that's a little bit different than graphing the actual results. Let's see. We'll just slide this over here. All right, let's change this up a little bit. We're going to look at the same game where we're flipping 3 coins. And looking at the number of heads, but we're going to change our random variable. So here our random variable was the number of heads. Let's change the random variable to be a certain number of points. So let's let x represent the number of points. And we'll just left align that so we can read it. So what I'm going to do is I'm going to copy, we're going to look at the same results. So we're still flipping our 3 coins, and now we are going to have a column for our number of heads. And we're going to choose some number of points. So this is our x value here. This is for our random variable. And we'll assign some points to this in a second. So this will be number of points. Again, these are our x values. The probabilities haven't changed. Just because I assign points to it, these outcomes are still equally likely, or as likely as they were before. Let's see if I can copy this whole thing. just paste it down here. And I think we'll leave that there. So let's say, for instance, that if you get 0 heads, you get 20 points. If you get 1 head, you get 0 points. 2 heads, you get 5 points. And 3 heads, you get 40 points. So let's just say that's a game that we made up to account for points. We'll center that. There we go. I'll center this column so that when we get there, we can use it. So now our random variable, remember, are the number of points. So these are our x values. Here's our probability. Now we want to do our column here for x times the probability of x. So again, we can use the spreadsheet features. Type in an equals sign. We want to multiply the number of points by the probability. Hit enter. And again, we can just use that little square in the bottom right-hand corner, drag down. And we should also include the sum because that's our expected value. So here we can see that the sum of the x times the p at x is equal to 9.375. So again, you get a certain number of points. The expected number of points, or the number of points that you can expect to win every time you play this game, is 9.375. So if this game costs 10 points to play, in the long run, you'd be losing every time you played. You wouldn't lose a lot of points, but you would lose a little bit. And this is how casinos and other games of chance are basically designed to win or to make money. So there's a slight difference here. It means you're going to win some, you're going to lose some, but in the long run, you're going to lose a little bit every time. So again, if this game costs 10 points to play, then you would be losing some. You as a player would be losing some money. If it were my game, me as a sort of game operator would be winning some money and or points. Now, if we wanted to change the game a little bit so that, for whatever reason, so that it was more enticing to the players, we can actually just fiddle around with the points. So let's say if you got 3 heads, instead of 40 points, we gave 50 points. So you can see if this were the setup for our game, the player would expect to win $10.63. Sorry, not $10. 10.63 points or 10.625 points every time they played this game. So if it costs 10 points to play, in the long run, the player here is going to come out ahead. And I know this is a small margin, but that's how casinos actually work. They want it to be exciting for you. They want you to win a bunch, so they try to make it seem like you're going to win a bunch, but the idea is that the game gets played millions of times, so this small difference here gets multiplied by millions of plays, which ends up profiting the game operators. So if we wanted to make this a game that was profitable, 40 points here instead would be a little more reasonable, not 400. So that's how we can use a spreadsheet to look at probability distributions. We looked at tables. We looked at how to make graphs. I guess we could make a graph of this one as well. Let's do that just so we can see that just as a reminder. So in order to make a graph here, we want to graph the number of points and the probability. So I'm going to highlight those 2 columns. Click on Insert Chart. So we can do it Insert Chart, or we can go for the little chart image here. It takes us to the exact same spot. And in this case, you can see that my chart is a little bit messed up. So we're going to fix this up a little bit and see if I can get the whole thing here. So what we want to do here is for the x-axis, we want it to display the number of points. So the number of points should be our x-axis. So we're going to add an x-axis, pardon me. It's saying select a range. So I'm just going to highlight this column, click OK. And it looks like it inserted that twice. So let's just see if we can fix that up again. Let's try this. Let's try that again. Under the setup here, the data range is there. Oh, here we go. The x-axis. It's saying B15 to B19. So it does have our number of points listed here, and we want to change the y-axis now. So the y-axis are the series. We don't want the number of points to appear on the y-axis, and that's what these little red spots are. Sorry, no, that's what the blue spots are. The red spots is what we're actually after. So we don't want the number of points to appear on the y-axis. So I'm just going to get rid of this. Click on the three little dots and click remove, and now we can see that we have our random variable. If we want to add a title, notice it didn't give us the option of doing a title this time. We can just click on customize. And right here, chart and axes titles. So we can give the chart a title, call it the number of points, probability versus number of points. And then we can change the x-axis, the horizontal axis. This is the number of points. And don't forget, these were our x values. And the vertical axis are the probabilities. There we go. So now we have a graph. I'm going to get rid of the chart editor since we're finished with that. Shrink this down a little bit. Now one of the things that's a little bit odd here, it just put these values in the same order that they were listed here in our table. It may have been worthwhile to sort those first. So if we wanted to sort them, I should show you how to do that, is just highlight the entire table, click on data, sort range, and we want to sort this probably by points. So points is the B column. So we're going to sort by column B. A to Z just means from lowest to highest. If we click sort here, now you'll see that it's actually sorted from lowest to highest, as are the values in the chart. So that's how we can use the charts. That's how we can use a spreadsheet to model probability distributions or to display probability distributions. The graphs, the tables, and we can make changes fairly quickly without having to go back and do lots of calculations.